Today, I want to talk about Lagoon. I don't want to talk too much about like how it, well, we will see how it works a bit, but I mostly want to see, or want to show you why we did it, because I have a lot of people that ask me all the time, like, why now another hosting system? And I also want to show you what is possible going to be in the future, because I see a lot of other hosting environments, obviously, but I also see a lot of systems that are outside of Drupal. And my goal is really to bring in all these new tools that are out there into the Drupal community, because there is a lot of cool stuff out there that we are not using yet. And with building these things with Lagoon, I really hope that as a Drupal community, we have even cooler tools. And I want to show you some of the stuff today that other people outside of Drupal are already using, and that will be possible with Lagoon. So Lagoon really comes out of a lot of pain points of development. Like Brandon mentioned, I used to be a developer myself. I'm the CTO of Amazee, so I hear all the pain points that all our developers have. I hear. So maybe you have some. What are your pain points of development when you work locally, when you deploy? Any things that you hate every day?
Content migration.
Content migration. Okay, we're not going to fix that today, but there is. It will help technically as well. Content migration. Other things.
Features.
Features. Yeah. So Composer. Yeah. So one of the biggest thing is that I always had is that locally is not the exact same as production. So there's some kind of different system, and there's different configurations, maybe different versions, or just something is different. And you never really are sure, like especially if the client tells you, oh, something is broken on the site, and you open it locally, and it's not. And then you never are sure, is it now something, is the database not synchronized, or is now maybe the PHP version different, is something else different? Like you're never 100% sure. And then the other problem is today, every site needs something different. If we look now within the couple of hundreds of websites that we run, yeah, you have PHP and you have maybe a database and you have a web server, but now we start to decouple, so maybe needs a Node.js, or one site needs a Solr 4, another site needs a Solr 6, that site has a Redis. So running that everything locally is very painful, like it's hard. Like you cannot just take another site that you never worked on, start it up and run it, because you might end up days, maybe even, to fix it. And then we use branches and pull requests for code reviews and stuff like that, but we can actually never look at the things. Like if you create a pull request, we might want to see, okay, how is that site actually looking if that code will be deployed? So we use branches and pull requests to organize our code and to organize projects, but we are not actually able to test that. And the worst thing, we are scared of deployments, because we don't do many deployments. And so we start to be like, okay, every deployment has like a calendar entry and has like checklists that we go through before every deployment to make sure, things like that. No, please don't log me out. 1 second. So all these things, and the reason for that is because we don't deploy enough. If you look at big companies, there is that famous thing that Amazon deploys every 12 seconds. Or there's other things that Facebook says, we are always deploying. There's never a state that a change is not happening. And these companies can do that because deployments are automated, deployments are tested, and deployments is actually something good. So all of these things we heard over the last couple of years, and I really thought, okay, there should be something out there that approaches all these things. And even better, it would be awesome if it's open source. So I really believe that we can fix a lot of these things and we can make them better. So a bit about the history of where we're coming from. So at the beginning, we used Vagrant for local development. Then in 2016, that was really too much pain. It was too slow. So we started to move slowly in Docker for development, because containers are starting much faster. And with that, also more and more, we got the first decoupled requirements. So in 2016, we started to merge to the first like React front ends and things. And then we actually realized that Docker would also be very good in production. And Hello. So we started to really use Docker in production more and more, and we said, okay, that's actually going to be our new thing. And last year we decided to actually open source the whole thing. And so a lot of people always ask me, like, why did you open source it? Why do you open source it? Well, for me, the big question between open source and proprietary hosting is, why do we even get the idea that hosting should be proprietary? Why? Why did somebody sit somewhere and sit in a bunch of open source environments and think, okay, like, why do I come up with code? Because if you look at any Drupal hosting, it doesn't matter. At the bottom, you have the Linux kernel. It's completely open source. Then you have the operating system, doesn't matter what you use. If you use Ubuntu or whatever, it's also open source. Then we have the MySQL. MySQL is also open source. Nginx, also open source. You see where that goes. We have PHP, also open source. And then we have Drupal, also open source. But there's one piece missing in between. That's the hosting platform. And somebody in this world thought it's a good idea to not make that open source, where everything else is completely open source. Everything else, I can look at the code, I can build the code myself, I can change it, and I can adapt it. But somehow we believed that the part in between should not be. And that's really the part that I think, or we think, should not be the case. So that's why we said, if we build something new, we're going to build it completely open source. So that means in Lagoon, you can see all Docker images there are. You have all service configurations. You have all build and deploy scripts. And the whole test infrastructure that is in there is there. You can look at it. You can tell me if it's wrong. We can fix it together. And we can work on that. And of course, Lagoon itself, because it is open source, it also has to use all the open source stuff. So we use OpenShift as an orchestration system, which itself uses Kubernetes, which is a Docker orchestration system, completely open source. And we use Alpine Docker images, which are basically super small Docker images for Nginx and PHP and Varnish and all these things. And some of them we even started to provide ourselves. So this is the whole open source part that we said would be awesome, and that's what we did. So how does it technically work? Well, it's quite easy. So you have something local. You push that to a Git repository. That Lagoon sits behind the Git repository and pushes that to OpenShift or Kubernetes, which then runs the Docker containers created from these Docker images. Sounds maybe a bit too easy, so I actually had to look it up. The opposite of too long didn't read is too short want more. Okay, so TSWM, and so locally we work with Docker Compose. We're going to see that later, how that exactly works. As mentioned, it uses a Git push, so you push into any Git repository in the world. That Git repository then forwards a webhook. So it basically informs Lagoon saying, hey, there's just has Git code being deployed. Do whatever you want with that information. So the Git itself doesn't need any additional things. It just needs to inform our system. And then Lagoon comes into play. And Lagoon basically reads that Docker Compose YAML file that you use for local development to configure all your containers and stuff is then read. And it builds the images for you fully automatically. It then talks to OpenShift, so it understands how to talk to OpenShift. It uses its API and basically pushes the images there, configures resources, and stuff like that. So this is basically what is necessary that an OpenShift can actually run a Drupal. And then OpenShift or Kubernetes, at the end it's both, then does all its orchestration magic. That means Lagoon is not a Docker orchestration system. It's just the system that tells another orchestration system what to do, because these tools already figured out how to run Docker containers in a good environment. And then Lagoon waits basically till a deployment is done. And when that happens, so when the deployment is done, it informs you like via Slack or via email. It can even call you when the deployment is done. It can send you text messages, whatever. It's completely pluggable so that you always know if a deployment worked, if it failed. You can also see the logs, stuff like that. So this is basically just how the whole system works. It really has that idea that you start locally, you push it, and you just wait, and then the deployment actually is done. Let's look a bit on the background if you're more interested in what it actually is. Lagoon is completely based on microservices. We don't have to go into each little details, but we wanted to make it fully pluggable into anything. So if you don't like Slack, you just don't enable the Slack part. You enable another system. If you have, let's say we use, for example, use Elasticsearch for logs. If you feel like I don't like Elasticsearch, you can just disable it. So it's really pluggable and usable, and you can really decide which parts you want to use. Because at the end, an open source tool is always about that you also want to maybe adapt it. And that is basically why we use microservices. Plus, I also really wanted to create a tool that actually uses microservices for real. So I thought, okay, let's try it here. It's a lot of fun. It's also a lot of thinking about and looking at that sheet a lot, but it's quite cool. Lagoon itself runs in OpenShift itself. So all you need to run Lagoon is actually an OpenShift. So if you have that, you can easily set up an OpenShift. You can deploy Lagoon in there. So you don't need anything else beside of what you're running already. And the bit inception part is that actually Lagoon can not only deploy Drupal, it can also deploy itself. So in order to update a Lagoon with the newest Lagoon, you tell a Lagoon to deploy Lagoon. So the inception part is there. So it's eating its own dog food every day because it's managing itself. Lagoon is completely integration tested. That means every time that we create a new, let's say there's a new Nginx image that comes out or an Nginx change, we literally start new OpenShifts and test that image completely from beginning to the end. So we make sure that we can install a Drupal in there. We can make sure that we can install like JavaScript in there and stuff like that. That's the really important part because there is a lot of moving parts. So you also always want to make sure that these image or that the system always works. So we can be sure if there's an update that the system actually works. Lagoon itself, and that's another important part, actually does not assume anything about Drupal. It knows a bit about Drupal in terms of configuration and stuff, but technically, you can run whatever you want to run in Docker. So whatever you can put in a Docker container, you can deploy with Lagoon. So we actually have a lot of clients that start now thinking about, oh, maybe I have that small PHP library that I also wrote, or I have a small Python script that I also want to run. All of that works. Lagoon does not assume. So whatever you can put in Docker, you can also run in a Lagoon. And that's actually quite cool because that means other communities, not just the Drupal community, can actually use that tool to deploy and to use it. And the other important thing that I heard a lot in the past is that people felt a bit caged in by forced processes of hosting providers. Like you have to go from development to stage to master. But sometimes that's not necessary. Sometimes you want to go from dev to master directly. Sometimes you want to make pull requests. Sometimes you want to be cherry picking or whatever. It should be the decision of the developer which process you want to use and not of the hosting system forcing on top of you what you need to use. So there is no first workflow in the whole system. Plus, you can actually define your own tasks that should run during building and rollout. So the system, again, does not assume anything. If you want to run a Drush feature revert on every deployment, you add it in there. If you don't want it, you remove it. If you want to run a Drush CR automatically, you can do that or not. So it's your choice to define it. So what is there for us? I thought at the beginning, there's a lot of pain points. So there is, or what does it currently fix for us? First, it provides you the exact same configuration, the same services, and the same versions as in production, because it runs the same Docker images. That means you have the same PHP configuration, the same Varnish, the same Solr, the same Elasticsearch, the same MongoDB, whatever you run locally, you can also run in production and vice versa. That gives you the certainty that it's not going to be a weird PHP configuration that the hosting company maybe does that you have no idea about. Then we provide, or the system provides, individual sites for every branch and pull request. If you want, for every single branch, it starts automatically a site that you can click around. It's a fully Drupal installed. You can play with it. You can test it. So that when you click that merge pull request button, or if you merge locally, you are sure that it actually does what you want. It supports automated testing. Because of Docker, you can also you can use like Circle CI or Travis CI to use these Docker containers to run behead tests, for example. We have clients that on every pull request that they open, they start the Travis CI, they synchronize the database into that Circle CI or Travis CI test and run behead tests over that on every single pull request. So they can be sure that every test runs. And they can be sure, because we use Docker, we can use the same systems again and again everywhere. What's in there for site builders? Let's say you maybe say, hey, I'm not actually coding, I'm more doing configuration. So we have full support for configuration management and also for features. It doesn't fix the problem of features, but at least it has full support for it. So, so that means we'll see later on every deployment, you can import the configuration and things like that. And if you want to change something in production and you're not exactly sure if it really will work or not, you can just easily create a new branch. It will create a test site for you within a couple of seconds, and you can test that there first. And if you're 100% sure that what you want to do, you can either export the configuration from there if you use Drupal 8, or you can then you can do it in production. So there never has to be that worry of like, ooh, if I now click here, what will happen? If you're unsure, you create a test site and you play there, you have everything there, and then only when you're sure. And then, of course, what's in for our clients? Well, happy developers produce better code, produce code faster. So the more happier your developers are, usually the more happier the client also is. That's an easy one. But the automated deploy system makes releases easy and painless. I've seen so many times where there is like a deployment on Thursday, and there's like a big, and like, yeah, everybody has to be in the same room and stuff like that. And that's maybe cool, but it's also bad. And that's what, of course, stresses the client, because they maybe have something on Friday that has to go out, and if that deployment fails, what are we going to do, and stuff like that. And that's obviously for the clients is super important that we have a system that makes it easy. Okay, a lot of talking. Let's actually look at it. So what we have here now is I have a Drupal example, which is set up for MariaDB. Doesn't matter at the end. So we have support right now for MariaDB or Postgres. Doesn't matter so much. So if I open that code in here, make that also slightly bigger. So to prove you, this is a regular Drupal. So it's a Drupal 8 we've installed with Composer, but at the end, it's pretty much everything is possible. So and what we see in here is the mentioned Docker Compose YAML file. And that Docker Compose YAML file basically defines what you need. We have example files for them, so you don't have to learn how to write them, but if you want to use them, so we defined like, hey, I want to have an Nginx container, I want to have a PHP container, I want to have a MariaDB container, I need a Redis container, I need a Solr container, I need a Varnish container. So that's the full-fledged Drupal site. Probably a lot of sites don't need that, but that's just as an example is all the things. And in there, I can now define which versions I want to use. So we have, for example, 3 different Solr versions. And you can see this is a Solr with Drupal. So the Drupal config for Solr is already shipped. You don't have to worry about that. We have a Varnish with Drupal. So Varnish is already configured. So you basically define that file. And what that file does is locally, you just run docker compose up -d. And that's not a tool of Lagoon or anything. That's just Docker Compose. And now it starts you all these containers. So you see these containers have been started. And on the very top, I define a route. So I can now open that link in my browser. And I can see I have I already installed the site before, but I have a full Drupal in here that I can play around, I can work with, things like that. So let's say I'm a developer at company blah, and I get the request to change the Drupal should move into the footer. Let's say that's a ticket in my project management tool or whatever. So the first thing I do, in that example, MariaDB is the master branch. It doesn't matter at the end which branch is the master or which branch is the production. In that case, that's just what it is. So the first thing I do, I go in here and I check out a new branch. I start with a fresh branch. Maybe I shortly pull to just make sure that I have the newest thing. That's good. So I start with git checkout. I move it a bit higher up. So, and I call that the Drupal footer. Oh, that already is there. Okay, let's call it the Drupal footer ADOC. Okay, so I'm in a new branch. And now I can actually do that. So I go to structure, I go to my block layout, and I take the site branding, which is the Drupal, and let's move that into the footer first. I save it here, and we see Drupal in the footer. Not a big or crazy change, but we see that. So you can completely work locally. You have Solr, you have Varnish, you can test everything, that it really works, stuff like that. So now, let's say I want to make sure that this site actually works. So I can now connect into the CLI container. The CLI provides me all the tools of like Drush, of Composer, stuff like that. So, and the other thing I can also do, I can connect to my remote sites. So the first thing I want to first do is I want to connect to the MariaDB branch that we saw before. I want to connect there via SSH. So I want to connect there and see how the current site actually looks like. And I don't know the URL of it. So all I run is I connect here, and now you can see that before now we are on the branch MariaDB. It's red because that's actually our production site. So I can run like a Drush status here, and or let's run a Drush ULI. That's even easier. Click on that, and now you can see before I was on Docker Amazee.io, which is the local site, and now here it actually opens me the Nginx Drupal example MariaDB. So that's my production site currently that is running, and I'm automatically logged in. And just to verify that you believe me, that the that site currently still has the Drupal in the header. So that's my local over here is in the footer, and this is the production site. So I now leave that here. So I'm local again, and I can now use my tools. So here we have Drupal 8. So I use configuration management, and I just tell Drush to export the current configuration. And we can see it shows me all kind of updates. I think they're all good. I do them, and now we can see here in Git status that there is actually changes. I maybe diff them, and I can see how, for example, the Bartik branding has moved from the region header to the footer first, but it also changed all the weights of the different other blocks. That's perfectly fine. That's good. So I add that, and I commit, and I call that the Drupal in footer. And I push that, and that push will be pushed to my GitHub. So I want to look at that. If I go here to GitHub, I can see here there is now a new branch. And that system is now set up to not deploy branches automatically, because in that system, let's assume that everybody can just push branches, but we actually want to only run specific pull requests. So what I would do now, I say, okay, create the pull request. I can see the changes again, and I can see the pull request goes from the Drupal footer ADOC into MariaDB. I can see my changes. I can create the pull request. Now, nothing will happen there yet, because that system or that project in Lagoon is set up that it only builds pull requests that actually contain a specific token. So you maybe don't want to deploy every single pull request. You could set it up, but especially in big projects, it might end up quite crazy. So what we have here in Slack is we have here our Drupal example folder or Slack channel. And now if I add the tag build to the title of the brand of the pull request, what will happen is that Lagoon realizes that there's a new that there is a new branch, a new pull request that contains the name build, and that is the magic token that Lagoon searches for. That's fully configurable. You can say deploy or whatever, and now it will automatically start a site for that. So what will happen exactly now? As we saw before, it will read through that Docker Compose YAML file and see all the different. You can see here that we also have some types. So we tell, for example, that the MariaDB should be of Lagoon type MariaDB. So this is how Lagoon realizes, oh, that's a database. It needs some persistent storage. It needs to open a port and all these things. So that's how it works at the end. And you can also define all your build times. So like what we want to tell Lagoon is we want to run composer install in the beginning. We want to run it with no dev because I don't need the dev environment on a deployed site. So here is your place to add all your things. So if you want to compile Sass into CSS, if you want to do whatever you can imagine, you can just add them in here so that every time that it's deployed, it runs fully automatically. And you don't have to remember, oh yeah, well, how do I deploy that site? Do I have to connect to a server somewhere or stuff like that? And the same also in here, like for the PHP, for example, here is where I define the version. So if you say, let's say PHP 7.2 just recently came out and you want to test the PHP 7.2, all you do, you change PHP 7.2, but you only change it in one single branch, means you test it there. The production side is not going to be touched, nothing at all, until you merge that actually in. So you can test it locally first and all the good things around that. So this is basically what the Lagoon is doing in the background. It's looking at all these different Docker Compose YAML files. It will go through the Docker files, things like that. The deployment, the first one, takes a bit because it has to install it from scratch. And to sneak now into it, to actually look at what is happening, we can shortly go and look. So in here, we see all the different, we can see here the Drupal example pull request 10. And we see here the build that is running. And it is currently, okay, so it is pushing Docker images into its own registry. So after the Docker images have been built, they will be pushed. And if we go here over to deployment, we can see already prepared all the things that we already saw from before. So the Docker Compose stuff is now appearing in here. So we have our CLI. We can see now the CLI starts to deploy because the image came up. And now that's all OpenShift and Kubernetes doing their stuff. They will now automatically run the different containers. They will arrive piece by piece, and it will be started up from scratch. Meanwhile, our production side is not touched at all. So the production side still has the Drupal in there. Everybody could work on there. These two systems are completely separate. They maybe don't even run on the same physical server. So that's important to know. They are completely independent Drupal sites. Whatever you push maybe in that branch will not arrive at the production side until you decide, means when you are actually decide to merge. So we can see there is more. Our Redis is booting. Then the Solr and the Varnish will come back. Yes, our questions so far until we wait. Yeah, sorry.
So when the build finishes, Slack's going to ping you back a magic URL? Okay.
Correct. We'll see that. It's going to take a bit.
Yeah, I was going to say, you're building all these images from your base
Yes.
Alpine image, right?
Yes.
Can you create, like if you have a standard image, you just create all the basic components of that image, save it, and use that?
Correct.
Instead of having to rebuild the whole thing every time, if it's the same every time, so you're repeating that process over and over again.
So
you know what I mean?
yes. So what actually Docker will do, we can do a second deployment right after, and you will see it's much faster because it reuses the cache from before. So it will reuse whatever you, if you like, if we go in here. If you know a bit about how Docker works, so first what we copy in is only the composer JSON and the composer lock and the scripts, and then we run the composer install. So the composer install will only run if you actually have changed something on these files up here. If you don't, the composer install will just be skipped and just go to the next phase. So that will be, it will be much faster. So Docker tries to reuse existing things. But of course, you could create your own complete Docker image that maybe already has some stuff in, so Lagoon doesn't even have to worry about that stuff. That would also be possible, yes.
Much faster.
It will be much faster, yes. So let's over here. So we see that all our services are running, and now we go to the builds, and let's go to the logs. Yes, so the next thing is, we have not, right now, we only have installed Composer, but we did not run any additional tasks. So there's another file called Lagoon YAML, and in here, you can define so-called PostRollout Tasks. So these tasks are run after all the containers have been started, the database is ready, the Varnish is ready. So what you can do, you can say things like Drush CR, not special, but we can also do Drush config import, or you can even write small bash scripts that allow you to define some logic behind. And one of the logic we have here is it checks if Drush actually tells us if it's installed or not. So I check, is Drush installed? Or is Drupal installed? And if yes, then this one will skip. If not, it installs from scratch from the config installer. So that means it will take the config that is shipped with that Drupal 8 that we committed before, and it will install a completely new site. But you could say, okay, synchronize me from the production side, synchronize to an SQL sync, or whatever that there maybe is. So it's really, it's your choice to decide, and you can add in here whatever you like. We have clients that put, that have like an information to an external system, to like, they automatically inform their Jira, so they add a comment to their Jira automatically that this has been now deployed. We have clients that use things like visual regression testing, so it figures out, oh, that is a pull request, so I need to automatically check two different design, whatever, you can all add them in there, and the system runs them fully automatically. And if one of them fails, it will inform us. So now all of that is done. And here's the magic link. So we can see here, we have now a link with Nginx Drupal example PR10. And so if I click on that, it will now open me the code for that specific site. And if everything worked, we can see here, the Drupal is actually in the footer, while on the production side, that thingy is still in there. And now I could, I can even connect to that thing. So if I go back into the CLI, and if I now run Drush SA, which basically tells Drush, show me all site aliases, I will see now the PR10 is automatically there, and I can connect to that site, things like that. And so whatever I might do, and so basically now it will be time to test that. And let's assume as a developer, my client decided, no, actually, I don't need that. The Drupal in the footer is actually not very cool. So, okay, we say we close the pull request, and we also delete the branch. And if we look over at our Slack channel, it tells me that the Drupal footer ADoc has been removed. The pull request has been closed. And if I actually try to visit the site that I had before, we will see that the site is already gone. It's completely shut off. So the resources that have been used before for that, all the containers are gone, everything is stopped. So I'm like I was before, and then I could go on. If I go back here and run like another Drush SA, we will also see that the PR10 is automatically gone, so I cannot connect to it anymore. So it's like before. So this really gives you the chance for each single pull request or for each single branch, you can test, you can figure out. You can really use the tools that other communities beside the Drupal community already have. They're used to pull request builds, they're used to branches, they run all these things. And now it's also possible in the Drupal sphere. And the cool thing is, of course, it is completely open source. So if you say, hey, that's actually quite cool, and I want to help. So it's completely, as mentioned, it's on open source, it's on our GitHub. And really don't worry, we test everything. So if you want to play with it, if you want to create your own Docker files or whatever you maybe come up, send us a pull request, it will automatically be tested. If it's broken, it will tell us, we can figure out what exactly. We invest a lot of time into the testing so that we can really have also people that maybe understand only a tiny piece. We have people that maintain only like the Django Docker image, for example. They have no idea about the rest, but they know how to run Django, even better. One of the big questions that people always ask is, why don't you have native Kubernetes support? And that's definitely something that might come in the future. We already have a couple of big companies that said, hey, we love that, but we want to use Kubernetes directly instead of OpenShift. That's perfectly fine. It might come. We might have more CMS support. There are already rumors that maybe next week a WordPress site will go live with it. So we also will, or there will be support for other CMSs out there, because as mentioned at the end, there is no assumption about Drupal specifically. Or just if you have ideas, it's an open source tool like Drupal. It's much smaller, obviously, but if you have ideas, come and bring them up. Don't be worried, or don't be afraid of maybe too crazy questions. So many ideas in there just came up through, why don't we do it that way? Or why couldn't we do that? And because our approach is really to create a tool that we all love, that we like to use every day. And we can only do that if we have as much as like information from everywhere. That's it.
Quick question.
Yes.
While you're building out your YAML file
yeah.
configuration, how do you know what your options are? Is that in the documentation?
Yes.
Okay.
Yes. So the YAML file, you mean for the Lagoon YAML file?
I was actually talking about
the Docker Compose.
Yeah.
So the Docker Compose is just it's all the documentation of Docker Compose. The only thing we add are these labels, and they tell Lagoon like what type it is. So like I tell like, okay, where should the persistent files be mounted? Like some people have different locations of that, things like that. But we have example files for all of them. They're all documented. And for the Lagoon YAML, the same here. Like I didn't show, for example, everything. You can also define like crons automatically. So you can say, hey, for the master environment, automatically run me a cron every 15 minutes. Plus, now we only saw like these super generated URLs that might not be the best ones. So you can also define your own routes. So if you say, hey, I actually have an own route, really cool is also there is automatic support for Let's Encrypt. So if you create a route, it will be automatically created as HTTPS. You have to say no to HTTPS. It's not that you have to say, you have to include, you actually have to exclude it, and it will try automatically to generate an SSL certificate for you, all that good stuff. And so, but all of that, of course, is documented. There is documentation on Lagoon read the docs.io. So there, it's everything explained, how to run it. And I have to say, I'm not super proud where we are right now with the documentation. So if you find something, send us a pull request for that as well. It's also part of the contribution, and will of course also be awesome if you see something or so.
And you have live customers using this right now?
Yes.
So this is not
No.
Bleeding edge?
No. We are using it. So the current status is that we have new clients already onboarded. We have a couple of quite big sites that are running that already. Basically, everything decoupled that we have is running all of that already. Plus, we are starting to migrate all our legacy stuff. But yeah, if we look into that OpenShift here, so that's the Swiss cluster. So we have like Texas Camp that will go live tomorrow, will be launched on here. There's a lot of different projects already out there that are running in there, and we're maintaining all of that. Yeah.
So if we're one of those people stuck on one of those nasty proprietary production platforms,
Yes.
How much of this can I use as a dev and then transition? Can I use this all the way up to like testing? Then when it gets to staging, put some hooks in there to get it into the traditional build process. So we could use a lot of this.
Yes.
We can't use the ultimate panel. Or
correct. Correct. And we have actually quite some clients that use it specifically for that.
Much bigger use case because a lot of us devs don't get to choose our platform.
Yes. So we have a couple of projects that are in there. All the settings files that we have. So if we go, for example, these settings files here that are specifically for Lagoon, they are all fully compatible to all competitors. So you can run a system at the same time on Pantheon, Acqueon platform, and Lagoon. So it is possible to run both systems at the same time, because everywhere we actually check, are we in Lagoon? And if we are not in Lagoon, none of that stuff is filled out. So you can run it. And we have a lot of clients that ask us specifically for that.
I mean, you have your Docker images. Do you have like already a DrupalVM version, or do you have a VLP setup or any of that?
So
or available, or do we have to build that ourselves? Or
currently, what we do is the images that we do are ours, or they are based on our implementation. Yes. One of the things that is very interesting is that there are other Docker systems out there, like DrupalVM or DDev or Lando and things. And there hopefully will be an BOF in Nashville to talk about how could we start sharing, relying on each other. My hope would be that there is actually only one Drupal PHP image for the whole community. So that Drupal for Docker, DrupalVM, Lando, Amazee.io, Lagoon, we all use the same image. Because at the end, the knowledge in there, it's just like, like right now, like yesterday, the Nginx failed somehow. And then you have 10 developers all trying to fix the same issue. Why? Like that would be really cool to work together in there.
And certainly one of our pain points right now is, that first round of QA testing, where it's really the devs testing each other's work. And it's really hard for me to share, my local environment to someone else. We're not Docker-based. We're not, any of these other things. And we, on top of that, have a network that's not really permissive of, my IP is visible to the rest of the world. So this might really be helpful to us.
It is definitely thought about to also use it as a dev tool only. At the end, if you never deploy a production site, nobody will ever complain. Like the system doesn't care.
But it can still hook into your traditional deployment process to start the handoff, right?
Correct.
And then you could take from there to your build manager or whatever.
It could, most definitely,
Yeah. So you guys are migrating. I think you said you guys are migrating old sites, right?
Yes.
So one thing, can you help me understand? So these utilize web servers and Elasticsearch. I heard you say, so that's an AWS account. There's costs behind that. Have you guys seen like a spike in cost? Because it seems like there's a whole lot of systems here. So like, have you guys seen like a really deep increase in cost from doing this setup?
It really depends what you are comparing it onto. Like currently we are migrating already clusters of like 20 to 25 VM or EC2 instances over to that system. And there it's pretty much the same. The problem is a bit, Docker itself, or the orchestration system, it needs quite some management behind. So you can run it on a single VM or on a single server, but it's more built for like multiple servers at the same time. the cool thing is that I didn't show, Lagoon will automatically shut down environments that you don't need. So if you don't visit a development site for more than 15 minutes, it will shut it down automatically. Means it will shut down all the containers. And then when you click on the link again, because out of any reason you visit it, it starts all the servers again. So the containers that are actually only running are the ones for the production environment. All the other ones, they're automatically idled, what is it called? And we see around 2/3 of resource savings because of that. Because yeah, you have so many dev sites that you probably never need. And that is how we count, because that's something like in traditional VMs is never possible because it takes too long. Like shutting down a VM in an Amazon instance is like something that takes a couple of minutes, and starting it again. And here with containers, it's much faster. So it's a good question. Costs can be a problem, especially if the current system is not too big. What we do, obviously, like as Amazee.io, as the company, we provide just hosting where you pay by how many sites you're running. So you don't have to worry about how many servers are there, and we make all of that sure. You just pay per how many sites you have there.
And if we were doing our own environment just for learning,
yeah,
you need to put it on Amazon. You can build your own Docker server.
Correct. Yes.
It's free at that point.
Correct. Yeah. So all you need is basically you need an OpenShift. There are documentations out there to run your own OpenShift server. There are even, I think there are on Amazon, there are AMIs that you can just use that are by default there. And you can just give it stuff and you can run it.
Thank you.
Other questions?
So say I had a bunch of PRs that I merged in.
Yeah.
And I go, oh, man, I should have built. Can I go back and tag those to build later on without, if I got the magic build keyword? You know?
Oh.
Yeah.
Yeah, you basically just reopen them here.
Oh, you reopen.
You reopen the pull request.
Okay.
And then you give it the name. I mean, a lot of times that is actually not configured. A lot of times we say, hey, developers, just be careful or be sparse with the amount of pull. Like create pull requests only for stuff that you actually want to test. So we say, okay, every pull request is automatically running. So, but yeah, well, I deleted the branch now, but basically what I would do is I can just push my branch again. And here I would reopen the pull request. And you can see here, it automatically opens the pull request and it will deploy again. So that's no problem at all.
Does it tag? Do you use git tagging to do that?
Right now, not.
No?
So we fully depend on branches. But if we go over here in Lagoon and we go into issues and we search for tag, we see here. So it is a question, yes, and it's technically not, like from a technical point of view, it's not that hard. We just never had, I would say, a client so far or a team right now that screamed loud enough that we felt, okay, we want to implement that. Because tags, it's just like, so you have to tag the Git branch and then you have to like run some webhook or something else. Because there is no way that I can like say in GitHub or so, like now deploy that tag. Like there is some like, how do I even use that system? So far we felt like the branches are the easiest, but from a technical point of view, it could be super easy to add that. Yeah, no problem at all.
Yeah, I would think git tags would be important because if something happens, you want to revert back to that point, right?
Yes and no, because the cool thing is, and so like let's go to our, let's say the MariaDB here, because you can see here that actually of the Nginx here, we already have the 7th version. So every time that you deploy a change, into the system, it builds a new Docker image and will run that Docker image automatically. Now, what you can do, I can just, and that is, I mean, we wouldn't expect for clients to do that, that it's handled by the API. But basically, now I see I have the deployment 7, and here I have the deployment 4, which was 11 hours ago. If I want to roll back to that, I can just click here, and it will start me the Docker images that have been deployed from before. So I don't even have to like redeploy stuff. I can just take the images that are still there. So the system keeps like the last 10 Docker images, it automatically keeps, and it will create a new deployment, the number 8, with now the rolled back code from before. So the rollback would actually not be necessary that you change a Git tag, or I want to go back to that. But I fully agree, tags will be there at one point. Like, it's not that they will never be.
So you did that, you roll back your environment, then update your code base and roll back your Git? Well,
no, it will not.
Still as it was, but you roll back this environment to that state.
Correct, yes. So it's a lot of like different ways of doing things.
It's a good thing. But
of course, yes. No, rollback scenarios should probably not be the ones that you run, like, or that shouldn't happen too often, hopefully. Yes, yeah, that's why you test. Yeah, you hopefully do not end up there, but technically it's completely possible. Yes.
If you test your own this, right? If you get something to test your own.
Yes, and to be fully honest, the next slight problem there is we roll back the code, the database is not rolled back yet. So there is, you can, for example, what a lot of clients are doing, they are adding to the Lagoon YAML. The first thing they do is they run first the database backup before they even start to deploy. And so then if something goes wrong, let's say you Drush UpDB or you Drush feature revert, somehow does weird things like they do, then you can still revert the database. There is, of course, also the other idea to use like snapshotting of file systems and stuff. That will be even cooler, but we're not there yet. Cool. Yeah, if you want to play around with it, either run it yourself or just talk to me. I'm happy to create you trial sites to play around with it. Like we give out free trial projects, so you can play with it. You can see how it works. And if you feel like, hey, that's a cool tool, then you can either completely run it your own, or we also definitely allow people to use our servers for that stuff. All right.